Okay, zeros, multiplicity, and polynomial long division. Okay, so first, mental health. I know my mental health has been on and off, but these are some 5 check-ins that you can do with yourself. How am I feeling today, mentally and physically? And answer yourself honestly. I know that I sometimes, I'll be like, I'm great today, and really, I'm not great, and then I have a breakdown, What's taking up most of my headspace? So what's going on in your head? When did I eat my last whole meal? Remember eating? Sometimes when you're not feeling super great mentally, we are almost like, oh, I'm not going to eat. I'm not hungry. But it's very important to eat. Am I tired? Yes or no? And if you are tired, should you take a nap? Or maybe your body's tricking you to think you're tired. Maybe you need to go for a walk or something. What will I engage in today that will bring me joy? Find stuff that brings you joy. I draw. I write a lot. There's other things. I go on hikes with my dogs. I just give my dog a hug. It makes me feel better. But check in with yourself mentally, please. Okay. Mental health is just as important as physical health. Okay, it matters. So check in with yourself. Okay, math. So zeros are also called roots, and this is where they cross the x-axis, and we've done a lot of this stuff. But, so this fundamental theorem of algebra is not the start of algebra, but it does say something interesting. So it says that any polynomial with degree n has n roots. So that means if we have a degree 2 polynomial, it has 2 roots. Now, some of those roots might be complex, so they might not actually cross the x-axis, but we will get to that later. So an even degree polynomial has an even number of real zeros, okay? An odd degree polynomial has an odd number of real zeros. Because again, it doesn't have to be exactly that, whatever the number is, since some of those could be complex numbers, and complex numbers come in pairs. Now, I will get into complex numbers a little bit later. But, so if we look at these polynomials here, so see how this is to the 4th power and we have 2 roots. So even. This is to the 7th power and I have 3 of them, which means 4 of them are complex. Okay, this one I have 4 and I have 0 roots, which is okay. 0 is technically an even number. This one is to the 5th power and I have 1 root. Okay, so an even degree polynomial has an even number of roots. An odd degree has an odd number of roots. Okay, we will get into the complex roots later. Okay, so factoring to find zeros. We've done this, so you know what you need to do. Now do it. We're going to factor out an x. Then you can factor that further to be x plus 8 and x minus 3. Set those equal to 0, so the linear factors would be x, x plus 8, and x minus 3. And the zeros would be 0, negative 8, and 3. So we could graph this if we wanted to. That'd be 0, negative 8, and 3. And then our end behavior here, remember, so it's odd and it's positive. So odd is the ugly, and it's going to go opposite directions. And it ends the positive direction. So it's going to start negative and end positive. So that starts down and ends up. Okay, and it crosses through all of those zeros because they all have a multiplicity of 1. And you're probably like, what the heck is a multiplicity? I'll get to that in a minute too. So this one, what? So if we have x to the 4th minus 5x squared plus 4, that's kind of hard to factor, but could we factor x squared minus 5x plus 4? I think we could. That would factor to x minus 4x minus 1, right? So we're going to do the same thing here, except break up the x to the 4th to be x squared minus 4 and x squared minus 1. Okay? So easy. Then we just factor it further. Those are the difference of squares. So I have x plus 2, x minus 2, and x plus 1, x minus 1. So our zeros are x equals negative 2, negative 1, 2, and 1. Sorry, I said that in a weird order. But anyways. So if we have all these zeros here, then our end behavior is an even power and it's positive. Even means they go the same way. Positive means they're both going up. So it's going to look like that. Okay. This one, so multiplicity, this word that I keep talking about. Well, let's factor this first. So x and x squared plus 10x plus 25. So that's x and x plus 5 and x plus 5, which I've had x plus 5 twice. There are two of them. So I could just put x times x plus 5 squared. Okay. So then our zeros are 0 and negative 5. But that negative 5 has a multiplicity of 2. What does that even mean? So if we think about, let's just go back to these graphs here. This technically has a multiplicity of 1, right? There's an multiplicity and exponents are kind of the same. Okay, so this has a multiplicity of 1, and we can see that we just cut right through the x-axis there. This has a multiplicity of 2, and it's like a bouncy ball. It bounced off of the x-axis. 3, cut right through. 4, bounced right off. 5, cut right through. 6, bounced right off. So what does that mean? Well, if it's an odd exponent, then it crosses through the x-axis. If it's an even root or an even multiplicity, it bounces off of the x-axis. Okay? So this one, if we have 0 and negative 5, well, that negative 5 has a multiplicity of 2, so it is going to bounce off of that negative 5. Okay, and we need to figure out our end behavior. So it's odd and it's positive, which means that it's going to end positive and start negative. So this graph looks like that. Okay, notice how it just kind of bounced off of that right there. Okay, this one, let's factor it. So that's x cubed, x squared plus 8x plus 16. That's x plus 4, x plus 4. So that's going to be x cubed and x plus 4 squared. So then we have a 0 with a multiplicity of 3 and a negative 4 with a multiplicity of 2. So if we wanted to graph this, there'd be a 0 and a negative 4. The negative 4 is going to touch and the 0 is going to cross because of the even-odd multiplicities. And then this is an odd power with a positive coefficient, so it's going to end positive and start negative. So it's going to look like that. Okay. Okay, this one. So what if it can't factor? And we're trying to graph this, or we're trying to do something with it. But you're given one of the linear factors. This is where division comes in hand. Okay, so we are going to learn polynomial long division. Long division with numbers. So let's see if we can remember how to do long division. So say this was 7 divided by 3, 4, 8, 9, 1, 9, 4. So the first step here is to divide. Does 7 go into 3? No. 7 goes into 34 4 times. Then we're going to multiply. 7 times 4 is 28. Then we're going to subtract. You get 6, and we're going to bring down the next number. Now 7 goes into 68 9 times. 9 times 7 is 63. So it'll be 5, 9. Bring down the 9. 7 goes into 59 8 times. So it'll be 56. 3. Hopefully this is coming back a little bit. So that'd be like 4, 28. It's 3. Bring down the 9. This would be 5, 35. 4. Bring down that last 4. 6, 42, and then 2. So this will be 4, 9, 8, 4, 5, 6, and 2 sevenths, which this 2 sevenths, that's the same here. Long division with polynomials is the same as long division with numbers, okay? So, oh, here's another one, but we're not going to do it. That's stupid. Okay, this. So steps to long division. First, you divide. then you multiply, then you subtract, then you bring down, and then you repeat. Okay? So for this one, we're going to start by dividing. And when you divide, you do first with first. And I would write this steps to long division down somewhere. So first with first, I'm going to do x cubed divided by x, which we get x squared, so that's going to go up top. Then we're going to multiply to the outside terms, so multiply to both of these. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. Then we're going to subtract, and when we subtract, it changes the signs here, because really, if we subtract, we can distribute that subtraction into there, which will switch both of those signs. So that'll be a negative x cubed and a positive 2x squared. Those cancel, and we have 6x squared. Bring down the 16. Then divide. Repeat yourself over and over. So this is just a lot of repeating now. So 6x squared divided by x is 6x. That's what goes up top. 6x times x is 6x squared. 6x times negative 2 is negative 12x. So that was the multiplying step. Now we're going to subtract, change the signs. Those cancel, and then I'm left with negative 4x. Bring down the 8. And then divide first with first. So negative 4x divided by x is negative 4. Goes up top. Negative 4 times x is negative 4x. Negative 4 times negative 2 is positive 8. Change the signs. Everything cancels. So that means that we do not have a remainder. Okay? And then if we wanted to, that means that this is our original function is x minus 2 times x squared plus 6x minus 4. Now, if that was something that easily factored, we could factor it, and then we could graph it, right? It doesn't factor easily. Our zeros are actually 0.606 and negative 6.606. And I got that from using the quadratic formula, which I wouldn't make you do that, but I will make you graph these with ones that actually factor, okay? But right now, let's just get down log division. So let's do this one. So we're going to start by dividing first with first. So 6x cubed divided by 3x is 2x squared. Now we're going to multiply. So 2x squared times 3x is 6x cubed. And 2x squared times negative 2 is negative 4x squared. Change the signs. You have negative 9x squared. Bring down the 12. Divide first with first. So negative 9x squared divided by 3x is negative 3x. That goes up top. Multiply negative 3x times 3x is negative 9x squared. Negative 3x times negative 2 is 6x. Switch, change those signs. Left with 6x, bring down the 6. Divide first with first, and you left with 2. And then multiply 2 times 3x is 6x. 2 times 2 is negative 4. Change those signs, and we're left with 10. And there's nothing left to bring down, which means that this is our remainder. And we can just put it over what we were dividing by. So plus 10 over 3x minus 2. Okay. This one, so here it looks like there is something missing. So notice, if we go along this, we have x cubed, x squared. We don't have an x, and we don't have a, we just don't have an x. Okay, so we don't have an x. So that what that means is we need to put in a 0 for where the x is. We have to put a placeholder there. So then we can divide this, and then we just go through the steps exactly like we were doing before. So 12x cubed divided by x is 12x squared. Multiply, you get 12x cubed plus 12x squared. Subtract, change those signs, and you're left with negative 8x squared. Bring down the 0x. Divide, negative 8x squared divided by x is negative 8x. Multiply, you get negative 8x squared minus 8x. Change those signs. Left with 8x, bring down the 4. And then 8x divided by 8 is, or divided by x is 8. Then multiply 8x plus 8, subtract, change those signs, and I'm left with a negative 4. Which means that that is my remainder, and I can just put minus 4 over x plus 1. You could also write this as plus a negative 4 if you wanted to. Either way is right. Doesn't matter. Okay? All right, bye-bye. See you later. Check in with yourself mentally. Make sure you're doing okay. Bye, guys.